Hi folks, Harry Frank from FX PhD, and we are kicking off week 3, class number 3 in our expressions bootcamp. I wanted to back up and cover some stuff that was in class 1. We had some great questions on the forums and some great answers. In fact, answers that are even better than I could describe. So actually, I will give a lot of credit to our friend Andiana here from Constance, Germany. I've actually been to Constance, believe it or not. But yeah, it actually provided a little bit better solution or answer to this because I answered this and posted it on Vimeo and put it in the forums. But as I've learned through experience, if this class gets repeated or some people just didn't follow the forums, this could get missed. So I wanted to go back and answer some of these questions real quickly. And actually, this one I haven't answered yet. So let's jump onto this one. First, the wobble is at the very start of the animation. It's very true. I did not cover this. I didn't even talk about it. If that bothers you, which it should, because this isn't how it should behave, what we're going to do is test for a certain case. So we're going to say, if this is at that 0 point, don't execute this wobble here. Otherwise, if it's at any other point, including all the way around to 60 seconds, go ahead and execute the wobble. So basically, we need one exception here. If it's less than 1, and specifically less than and not equal to, don't do this code right here. So what we need to do is set up an if-else statement. So what we can do is test for a situation and say, if this case is true, if this situation is true, do something. If that's not true, do something else. That's the if and the else. So I can say, if something is true, and that something is going to go in parentheses. This could be if this is equal to that, or this is greater than that, this is less than that, this is not equal to that, this is greater than that and less than that. There's a lot of things we can do. So we'll do this very simple one here to start out. We're going to say if time is less than 1. If time is less than 1, it's basically going to be 0. And we don't want to have this thing wobble. So if time is less than 1, if it's less than 1, we don't want it to execute the wobble. So what we're going to do is say, use a value of 0. And actually, this might make more sense if we flip this around the other way. If time is greater than 1, if it's greater than 1, we want it to do the wobble. So what we're going to do is, in these brackets, everything inside the brackets, after this case that we are testing for, everything inside the brackets, from this bracket all the way down to the end of that bracket, all of this code, as many lines as it is, will get executed. So if it's greater than 1, do all this. However, if it's not, do something else. So let's say else, and then in brackets, well, technically we don't even have to have brackets. Brackets are really just to execute multiple lines of code. I could actually just say else 0. But I guess it would be considered good programming etiquette to go ahead and put it in brackets like that. That would also work. And in fact, if you're very detail-oriented and you want it to be, well, normally in programming environments, real programming environments, chunks of code like this can usually be collapsed. Chunks of code that are inside brackets like this, we could take these in collapses, but not in expressions. Just know that you can arrange it however you want. In fact, I often just put stuff like this on one line. So we've said if it is less than 1, do all this, else just do nothing. Just pass 0 off to the rotation. So that's one way to do it. And that was one question. The other question was about the difference between math round and math.floor. Now, let me actually get this back to, well, no, this should be fine. I'll leave the if else in here. But what I'm going to do, well, you know what? No, I'm going to remove this because this way we get back to where we started. Now, let me do this. I'm going to put 2 forward slashes on this line here. Basically, it's going to make it a comment or remark, and it is not going to be part of the expression. Or this code over here, anything to the right of those 2 slashes, is ignored by the expression. So what we're going to have is just this value right here, time minus the rounded time. So it's that repeating value that starts at 0 and goes to 1/2, I believe. Value ref. Now it's starting at 0 because we used floor. Floor always rounds to the lower integer in the rounding process. So 3.1 gets rounded down to 3.0. 3.5 gets rounded down to 3.0. 3.999 all gets rounded down to 3.0. So when we take these and do the subtraction, we always end up with a repeating pattern that starts at 0 and goes up to, but never actually hits 1. It goes up to 0.99999. But it repeats over and over, and that repeating pattern is what we use to plug into the exponential decay here. So it starts at 0 and increases, but it's never negative. Now, when we plug in something like math.round, and we do the math and we subtract, we do end up with a negative value. You notice that the graph right here with 0 right here, we end up with negative values that go from negative 0.5 to positive 0.5. And if we plug in the values there, we actually get a really a different set of values when this executes into the exponential decay. And as a very good point pointed out in the forum, this is where I said our members are jumping in to help and raising very good points. When we're plugging these negative values, we have this division problem. We have, remember, back to your math, we have what's on top of the fraction and what's at the bottom of the fraction. We have the numerator and we have the denominator down here. It's on the right, but think of it as a fraction. We have this on top of that, and what we're doing is plugging negative values into this exponential decay down here, or the math, or the exponential function. Plugging negative numbers into the denominator, and what we're going to end up with are very, very, very large values because we're plugging a negative value into it. And we don't want to do that. So that's one of the reasons we want to stick with math.floor. Now, the values are really large. We could just say, yeah, use a lower value. It also starts off in the wrong spot because we are using a negative value. So then we'd actually have to subtract. So we could get it that way, but this is not the right way to do it. Stick with math.floor. In fact, what you're going to find is that when you're rounding numbers, I most often use math.floor. Any expressions that you see floating around the internet on any of the very helpful expressions sites like Creative Cow or whatever, you'll often see floor used because it's much more predictable than using round, because you have these values that flip from negative to positive and can really screw things up. Hopefully I covered all the answer or questions that were in here. Oh, and lastly, this actually had to do with the minute hand and subtracting 180. I think in one of the examples that I had, which was simply flat out wrong. I shouldn't have had that in there. If you do use math.round, you would actually have to subtract 180 because we're starting 0.5 off from one or the other. But I should have actually eliminated that. So we're all good. We're all fine here now. So on to the material that we covered last week, or last class in class 2. And what we're doing is setting up a sort of a UI mimic, and I think I called it ScreenFlow, which is actually the recording program I use, and I should have called it CoverFlow. That was good. Have some mercy on me. I'm in the middle of a lot of projects at work, and I'm in the middle of a move, an interstate move from Los Angeles to Portland. So if I seem a little scattered, that is why. I'm trying my best to keep up. So anyway, we did this. This is pretty cool. But we have a lot to do. We have a lot to add here. Now, I'm going to level with you. When I go through and I make expressions, and let's say you look at this one, I don't just write this whole thing out top to bottom when I'm creating the expression. At least that's how I work. I'm not a programmer by trade. I'm an animator, and I do design, and I make things look cool and have particles and explosions and stuff like that. So I'm not writing code, heavy-duty code every day. So when I am presented with a problem like this of like, well, I want to make this sort of cover flow kind of thing, I start and I break it down into components. Like, well, I know I need to move it left to right. And that's where we started. This was a big chunk of what we did. Well, this is all we did last week. So let's move forward and tackle some of these other problems and look at what we need it to do. These, well, obviously they rotate. So they rotate in and out. They also move forward in the z-axis quite a bit. And they also stagger from one to the other. So there's some sort of code that's taking into consideration that there are multiple layers and that they need to be delayed based on the number of layers in there, or at least its stack or its position in the layer order, or its position in the stack, I should say. But anyway, you know what I mean. Each layer should be delayed from the last so that they're not all in the same space. So these are all the problems we have to tackle. And it's a lot to think about. It's like, well, where do we start? So let's pick something not so complicated, like rotation. Rotation's pretty easy. So let's take a quick peek at what we got here in the final. So we're just working with 3D layers that have a Y rotation. Hey, that's not so bad. A lot of this is... well, some of it is allowing some flexibility using global, kind of mimicking global variables, so we can adjust things like the range and all that of the where it starts to rotate and all that. So don't get too freaked out by this. The bulk of what we're going to be doing is just these two things right here. We've seen these before. We've seen linear before, so we're using linear to output stuff at this rate of something called progress, as progress goes from 50 to some sort of range, and then we have some fixed values here. Oh, 50, sorry, at the rate of progress, go from 50 minus some sort of range to 50, and then output negative 85 to 0, and this rotate out is outputting 0 to 85. So it looks like they're rotating from negative 85 degrees to positive 85 degrees. They're rotating in 85 degrees and rotating out 85 degrees. That's mostly what we're going to do. And then once I have those declared, I just add them together. So the negative rotation and the positive rotation add together. So let's get that far. Let's just get this basic rotation set up. So first, make sure this is a 3D layer, and let's look at our Y rotation. So I mentioned briefly that I had some sort of global-ish variable. And let's make sure let's get rid of that on there. Now, this gets into the heart of expressions and expressions technique and expressions, just how they fundamentally work. A lot of programming environments allow for variables and things to be sort of written and stored and accessed globally, so that I can say, here's one value that is going to be accessed by a lot of different things. And we can't really do that. When we create an expression for any given property, all of the variables and everything that happens in here is all self-contained within here. So any variable that I use, x, y, z, a, b, c, inside this expression for this parameter, y rotation, those are not going to interfere with any other variables that exist in another expression, x, y, z, a, b, c. Those are all independent. So there's no global variable that we can really assign inside an expression. So we do some workarounds, and one of these is to use expression sliders and hand off the values that we want to use into these sliders that just kind of sit there and allow numbers that change to be accessed by other expressions. That probably wasn't a very good explanation. So let me go in here and go to expressions slider, and I'm going to rename this progress. This is, in fact, I could, if I want, I could do G progress. G, lowercase g, usually defines a global variable. So this is going to be the progress of this thing right here from 0 to 100. And what I'm going to do is take this slider right here, put in some expression magic, and translate this value from its starting point to its ending point, and have this take on a 0 to 100 progress slider so that I can access. So that way I'm not accessing these random values of like 150 to 650 as my beginning to end. I want 0 to 100 because I want to make things simple for myself. So let's do that. So we're looking at our little handle here. Mine's called handle 2 because I copied it and pasted it. So let's just keep it simple. Let's name it just handle. And let me look at this expression right here. So we said our beginning was 300 and our end was 1000. Using fixed values like this gets a little tricky, because if I start duplicating this and I decide that I want to adjust that edge, that beginning and end, we're going to be kind of screwed. So I would also probably want to do something like this where I add 2 more. So I could say start position and end, E-N-D. Sorry, I don't have any lamps in here because they're all packed because I'm moving. So let's plug in those values, and if we want to adjust these later, we can. So I have 300 and 1000. And before we get too far, let's just grab these. Go to our effects here. Let's lock that. And now if I select this layer, let's pick whip, start position, and end position. So this should be exactly the same as it was before. It's just more modifiable now. Okay, so those values are our beginning and end. And now because they're variables, I can actually see them right here rather than digging in through all this code right here. So this slider right here, I want to have it move from 0 to 100 as this thing here moves from its start position and end position. So we're probably going to have some sort of linear relationship, right? We're using these over and over. L-I-N-E-A-R. So we're going to have a linear relationship at the rate of this thing's x position. So rather than have all of this big long thing here, let's use some variables here. X position. This will be equal to the x position of this guy right here. And we also want those start and end things. In fact, I can just copy and paste this. Well, you know what? I don't have to do that because those are contained right here. So I could say start. You notice it doesn't need all that gobbledygook of this comp, this layer, et cetera, because it is this layer. So if I don't define that, it assumes that we are looking inside this layer. So we're looking at an effect called start position and then using its slider as its value. That's why I didn't copy and paste that, because we didn't need that. And I wanted to bring that point up. So start and end. Okay, so we have our x position, that's the rate. The start and end are where what we're going to map, or the values we're going to remap. So a linear relationship at the rate of x position. As x position changes from start to end, output values 0 to 100. So at this 300 point right here, it's at 0, and then as I move this over, we have our global progress that goes from 0 to 100. Now I can have all these other layers reference this global progress and have a nice 0 to 100 progress to follow along. Also, notice that I can drag this way outside of the actual range that I need it to go. And I don't want it to do that. I'd rather have it stuck to the values here of that 300 and 1000. So what I'm going to do is use a clamp. This is under, I think it's under vector. No, it's not vector math. It's JavaScript math, right? No, it's not. Is it vector math? Yeah, it is vector math, clamp. So we are going to clamp a value and limit it between two values, limit 1 and 2. So clamp, or this whole thing here, will output values limiting value here, limiting this value, between limit 1 and limit 2. So what we're going to do is, let's say x is equal to this position 0. And then I am going to clamp. I mean, I guess I could just do it like this. Well, that's not overcomplicated. Clamp, and then in parentheses, we need three things: the value that we're clamping and the extreme values from one bottom limit to one upper limit, or one lower limit to an upper limit. So I could manually type in 300 to 1000, but if I change that, then we have to go back and change it here. Now I could pick whip it. So I could say limit it to the start position and end position. That to me, well, let's come back to that error. That just doesn't look very efficient. It's hard to take this apart with my eyes and say what the heck is going on here. So let's just do our start and ends here. In fact, yeah, well, let's just do this real quick. Start and end. Hopefully this amount of repetition will help you learn all this stuff that much better. So start and end, E-N-D, E-N-D. I need to go get a lamp. So we have this value that we're clamping, so I'll set this to, let's just set this to a variable. X is equal to a clamped value of the position, and the position will be clamped between this start and end. So instead of handing off position 0 and 500, remember we put 500 to lock the y-axis, I'll put X in here. Whoops, and now I grabbed it and scaled it. So now this is going to be clamped between those two values. If I go up here and adjust this start position, this will allow me to start a little bit further over here, but we're still dynamically updating that global progress, and everything is happy and working. Okay, so let's actually get to that thing that I said we were going to get to, which is the rotation. Now, I took a little detour in doing some setup, but trust me, setting variables that allow us to adjust things on the fly really simplifies things. So it's not just about understanding expressions necessarily. It is, or being good at math, which apparently I am not always, but knowing the syntax and knowing an effective way to do it, because once you get into fairly, deep expressions, or a little bit more complicated, like what we're doing right now, having a little bit of setup like this and things, these little things that will make it easier, I think are really helpful. So let's dive into that rotation right here. So this is as far as we got. So what we're going to do is have it rotate one way when it's, let's see, over on that side, and then flip back around and rotate around the other way. So we're going to do this pretty simply. We're going to use two linear relationships, and we'll say as this progress goes from a certain value before 50, which is the halfway point, and 50 is pretty easy to figure out rather than the halfway point between 300 and 1,000. And this could vary depending on the size of your composition. Let's say if you're doing this for a really large projection screen or something like that, you could have a very large resolution in here, and you can have very large values that might be fairly arbitrary. So hitting that midpoint with our global progress is pretty easy now. So we need to get that 50 or some point before 50 to some point after 50. So I'll do this with fixed values, and then we might actually, again, go back and make some global variables that make this easier. So let's set up our two relationships. So we're gonna have two variables here. We'll have rotate in is going to be equal something, and rotate out is going to equal something. And then down here we will have rotate. Sorry, I was just looking to see if I had a flashlight. Seriously, I am kind of in the dark here. Rotate in plus rotate out. Often when I really have no idea what I'm about to do in terms of the expression, this is where I start, even though this is going to give me an error. Okay, this is the basic idea of what I'm going to be doing. Rotate in is going to be something, rotate out is going to be something, and we'll add those two together to make two different rotations that happen before 50 and after 50. Yep, thank you. Okay, so we are going to have a linear, actually, we don't necessarily have to use a linear relationship. Okay, I'm going to set it up as a linear relationship, and we'll go back and explore a different way to do this. So we're going to use linear, and then we're going to reference this progress right here. So let's grab that global progress. In fact, I don't need it to be here. We'll just use progress. Progress is equal to this thing over here. That it's on the handle effect global progress slider. So that progress is equal to the 0 to 100 progress of our handle as it slides from 0 to 100. So we're going to say at the rate of progress, as progress moves from some point before 50 and some point, some point before 50 to 50. So that range is something we'll probably want to be able to adjust, but I'll just use some fixed values. So we'll say from 25, so when this image is about over here, we'll start to rotate it to 0, so it's flat to the screen. So we'll have this go from negative 85, to 0. And then the rotate out, we'll have linear, the rate of progress. As this goes from 50 to, the counterpart to that would be 75. So it's 25 to 50 and then 50 to 75. 25 to 50 will rotate in, 50 to 75 will rotate out. 85 to 0, and then this will go from 0 to 85, right? I think that's right. Let me cheat and look at what I did. Negative 85 to 0, and then 0 to 85. And then we add those together. Okay. So it's negative 85 until it hits 1/4 the progress. And then we start adding a linear relationship as the progress goes from 25 to 50. And then at 50, it's exactly flat to the screen. And then back over here. Now that's a pretty wide range there. We actually probably want it flat to the screen a little bit earlier. So maybe at 40 and at 60. So now it's going to go from 1/4, and then at 40, it's going to be flat, and then at 60. That's all stuff we would probably want to find as variables. What that width of the range is in terms of when it starts to rotate one way and the other way. So that would be some sort of transition range, which you'll notice in my thing right here, the finished version, I have a transition range. So it's another slider that I set up that allows us to dynamically adjust that transition range. So when you saw that and were confused about it, now kind of makes sense. So let's adapt, or let's put that in here. So let's add another expression. This will actually probably be the last thing that we're going to do because this is global, because I need to keep this class between 30 and 40 minutes because we've been yelled at to not do that. So, or not go over 40 minutes. So this is global trans range. So this is the transition range that we can globally define for all of our layers to say that, 20% or 30% or whatever. So right now I have it, it goes from, let's see, goes from 40. Well, we want it to start at 25 and it goes until 40. Well, we can easily have two different sets of variables in here. I just made it set from 50. So let's say we'll have this go to 50. Yeah, let's leave it at 50. So 50 to 50. So our transition range here, let's set this to, let's say, 25 now in here. So if I say 50 minus that transition range, so let's grab that trans range and pick up that transition range. Yep, hold on. Transition range, okay. So 50 minus that transition range, capital R range, that is going to be 25. This right here is equal to 25. 50 minus that transition range. So it's going to go from 25 to 50, and then 50 to 75, which is 50 plus the transition range. So we've set up an adjustable start point. Basically, this transition range is a width from here to here in terms of where it starts and ends. Now, we can also set an adjustable point of where it ends. So basically, it flips flat to the camera before it hits that 50%. That might be getting I'm sure you get to the point and you don't need to sit and watch me do it. In fact, why don't I pause and save us the time here. So I'm going to pause, set it up to do an adjustable transition trans range end. There. So I got it set up. You didn't have to watch me do it. But basically, I did the same thing where I set up a transition range end. So we still have the fixed values of 50. So that's that end, or that middle point. And then I'm subtracting and adding that adjustable range. So right now it's set to 0. So it's exactly the way it was before. The only point at which it's flat to the camera is right at 50. But if we like to widen that a little bit, so it starts, it hits that flat point a little bit earlier, I can adjust this, maybe set it to 10 or so. So we'd have a range. Now, I mentioned earlier that there's a different way to have this adjust or create this relationship. Right now, we are using a linear relationship. So basically, as this moves, it has a linear move from this rotation value to that rotation value. There's no ease or anything. It's a linear relationship, so there is no easing in or easing out of values. So if we want to break outside of that exact linear relationship, we can ease. We can actually use the word ease, so that eases in and out of these values. In fact, we can use things like ease in, so it only eases into a value, but uses a linear relationship out. Or we can just use ease, and that actually makes it a lot easier. So it actually has an easing value from one. So it's no longer a linear relationship. As one moves, one directly moves in a direct linear relationship. It's actually using an eased or a curved Bezier relationship, which is why I always teach this well after covering the idea of linear relationships, changing or remapping values using a linear relationship, using variable rates. Such as, something like progress here, which is a global variable that we set up to monitor the exposition of this thing that we move. What we've done is actually pretty complicated so far. This is some good stuff. So next, what we need to do is do a little bit of the Z push, which is actually pretty easy. But then lastly, what we need to do is account for its position in the stack. So if I have a bunch of these, how do we have it keep track of all these different layers and delay them based on their layer? And also, we probably want some variable spacing in there so that, oops, let's unlock this. Let's go to my handle here. So that we can actually, spread these things out so we can have a different type of offset like that, or squeeze them together. So that will spill into next week. I would tackle it this week, but like I said, we've been told specifically to try to keep these between 30 and 40 minutes. So that way it's more digestible for you and just not feeding you too much, especially when we're dealing with expressions. I think we've done enough here. And I think it's good to cover this step by step via video. Every time I've ever seen a written expressions tutorial, my eyes just glaze over. I know looking at this right now, it does seem like a bit much, but because we've gone through it step by step, I think it should make pretty good sense. And actually, at this point, we should probably start adding nice little spaces and comments in here. You notice I mentioned that earlier about adding comments where we can say, declare our variables up here and here, and then set our relationship for rotating in and out, and then output values to rotation, that kind of thing. Whatever makes it easier for you to digest and look at and feel good about. So anyway, we'll finish this one up next week. And by next week, holy cow, I will be in Portland. I'm moving to Portland next week. So wish me luck. And hopefully when I'll get around to recording the next class, I'm not sure, but we'll do that then. So anyway, thanks so much. We'll see you in class 4.